Constructing Classes, Part 2. In the previous video, we saw that the class width with 6 classes would come out to be 38. So when we construct classes, the traditional approach, the one that has the least amount of bias in it, because it simply works with the data as it is to start the first class at the first data value. Now, we also need the upper limit of the class, and then the lower and upper limit of the next class, and so on. Oddly enough, we actually are not going to get the upper limit of this class right away. What we're actually going to do is find the lower limits of each class before we find any of the upper limits. The class width is the difference between successive lower limits, or between successive upper limits. So what we're actually going to do is take the class width and we're going to add it to the lower limit of the first class in order to get the lower limit of the second class. And so on down the line. If we keep adding the class width, it will keep telling us the next lower limit, and so on. Again, feel free to use a calculator to get these values, totally acceptable. Now, from here we can get the lower limits by observing some of the rules for constructing classes. The rules say that the classes must all be the same width. We have ensured that by making sure it's the same distance from one lower limit to the next all the way down. The next rule says that the classes have to be mutually exclusive, meaning you don't want them to overlap. You don't want, for example, one class to run 83 up to 125 and the next class run 121 up to something else. This is a distinctive overlap. We have a problem here if we have a data value such as 124. 124 fits in here, but it's also bigger than 121 and would therefore fit into that group. We never want that to happen. So there should be absolutely no overlapping values between the classes. Likewise, there should not be any space in between them. We don't want to have one class only run up to, say, 115 and the next start at 121. What if we have a data value of 118? It has no place. So every data value must fall into one of the classes. And really, there's only one way to do that. If this class begins at 121, then the last class must have gone all the way up to 120. Now, from this point, we have two ways to proceed. We can either, as before, use the class width and continue that pattern all the way down. Although, admittedly, I think that that's kind of silly. There's a much better way to do this. If we can find the upper limit of one class by knowing the lower limit of the successive class, then we can continue to do that all the way down, well, almost to the end. So if the third class begins at 159, the second class must have ended at 158. If the fourth class begins at 197, then the third class must have ended at 196. This will work for us as long as we have another class to read off of. As long as we know where the 235 begins, then we know where the previous class ended. This will serve us well until we get to the very end, when we suddenly run out. We can't tell what the upper class limit is here by comparing it to the next class because there is no next class. This is where this pattern will come in handy. Yes, it could be used, although it's kind of slow. It could be used to populate the upper class limits. Down here, it has to be used to get the upper class limits. There really is no other way. And these are the 6 classes we will be using. Now, if we have a different number of classes with a different class width, we would see some slightly different values in the limits, the lower and upper limits for each class, of course. Now, one interesting thing you may have noticed here is that from the class width calculation, we know that the largest data value is 308. So why did we go past 308? Well, for one thing, this keeps the idea that all of the classes are the same width. If we cut this one short just because we know there's no data past a certain point, then that class would no longer be the same width as the others. This does tie into why we always round up, just by the way. Rounding up means we're likely going to have a few extra values in the last class, even though the largest data value stops at some point before that. Like in this case, 309 and 310, if they occurred, would fall into this class. We know from our sample they do not occur, but it's better to have that extra space than to run out. Now, this is the correct class width and the correct class limits for 6 classes. In a future video, I will revisit these. I don't want to do it right now because I'd like to keep us working with the correct numbers. But in a future video, I will come back and say, what happens if we do not round up? What happens if we round down? What happens if we don't round at all? And we'll get a chance to see why it's so important that we round up. But this is the proper way to do it. We start the first class at the lowest data value, the smallest data value in the entire set, and we add the class width to establish all of the lower limits before finding any of the upper limits. The upper limits then come from adhering to the rule that there should be no gap and no overlap between the classes.